Okay, we have a video here on A16. And on assignment 16, it's going to start by giving you what we call a mapping diagram, which looks like two ovals with some numbers in it connected. It'll look something like this. Okay. And the first thing it's going to ask, what's the domain and range? Which is very simple. You just have to memorize a little bit here. The domain are the numbers on the left. They're also called X's, which they're called here, or sometimes inputs. So the domain here is simply the list 1, 2, 3. The ranges are the numbers on the right, sometimes called Y's, which they are here, or other times they're called outputs. So the range here is 4, 5, 6. So you're going to be asked to list the domain and range. You're also going to be asked, is this picture a function? Okay, and it's a function if every number on the left corresponds to exactly one number on the right. So here 1 corresponds to 4, 2 corresponds to 6, 3 corresponds to 5. So yes, this is a function. Okay, and we'll show you other examples that are not functions in a minute. Okay, so that's our first example. As a second example, draw a new diagram. Let's say we have, this time we call it input and output. All right, we'll go 7, 8, 9, 10, 11. Okay, it looks like this. 7 goes with 10 and 8, 9 each go with 11. That's your domain and your range. Okay, remember domains and numbers on the left. They're sometimes called X's, sometimes called inputs. Here they're called inputs. There'll be 7, 8, 9. Real simple. Range, numbers on the right, sometimes called Y's. Here they're called outputs. 10, 11. And you'll be asked sometimes, is it a function? Okay, remember it's a function if each number on the left corresponds exactly with one thing on the right. And yes, this is a function. And immediately people say, wait a minute, what about 8 and 9? They both go to 11. Well, true, but 7 goes with exactly one thing, 10. 8 goes with exactly one thing, 11. And 9 goes with exactly one thing, 11. You're asking the numbers on the left, not the numbers on the right. Numbers on the left, are you going with exactly one number? You can kind of think of it as dates at a dance. These are the boys, these are the girls, whatever. 7's going out with 10, but 8 and 9 each go with 11. Okay, might be a problem at the dance, but as far as asking the boys, yeah, 8's going out with one girl, 11. 9's going out with one girl, 11. So this is a function. Okay, the last example, I'm just going to erase some of this instead of having to rewrite it. What if this time you've got the number 12? The numbers aren't really that important. I'm just changing them for illustration purposes. You've got a picture like this. Okay. The domain here is 12. The range is 13, 14, 15. Okay, domain's the number on the left. This time there's only one. Sometimes domain's called X. Sometimes domain's called input. Here's input. Range, there's 3 numbers, 13, 14, 15. They're called outputs here. Okay, so there's the range. This time it's not a function. Okay, again, because each input, which here is 12, does not go with exactly one output. This boy, if you want to call it that, is going out with 3 different girls. Okay, the boy or whatever's on the left has to have exactly one match, not 3. So this would not be a function. Okay, so that's the first part of A16. The next part, pretty simple. We've already kind of done the next part with just with different notation. It's going to say f of x equals 4x minus 1. So what is, for example, f of negative 4? Okay, you just have to kind of get over the notation here. On A15, we call this, in A14, we call this f of n, but now it's f of x. Just a subtle difference. N became x, but you do it the same way. What's I want you to do here is replace the x with a negative 4. Okay, that's easy enough. And then they want you to work it out. Okay, 4 times negative 4 is negative 16. Now use decimals here. We haven't done a great job with our signs, our arithmetic. So we want to use decimals here to get negative 17. Now notice the left-hand side never changed. It seems like maybe this is incomplete, like maybe you should divide by negative 4 or something. But no, this is a notation which makes a correspondence between what you were given to put in. Negative 4 was given to you in the problem. and what comes out as a result of putting that in. -4 matches up with -17. So you leave it like this. F of 4 equals -17. So it's just really the order of operations with a kind of a new notation. What about f of, let's say, a new f of x? And I can't remember what it says on assignment 16. They change the f sometimes to g or different letters. But here's, we'll say f of x equals 1/2 x plus 8. Let's find f of 6. Again, you simply put 6 where x is. You don't worry about this side at all. Just keep writing it. Half of 6 is 3. And 3 plus 8 is 11. So f of 6 is the same thing as 11. Again, you see a match between 6 and 11. Again, you do not divide by 6 here. It's just an order of operation problem. That's really all that is. The last part, or one more type of problem from A16, you may be given a table. It'll say x and f of x, and it may ask you to something like this. What is the function that goes with this? There's a little technique here. Remember, these are arithmetic. We're working with linear functions. So you should notice that we're adding by the same number on the side. So what I want you to do is say f of x equals that number, whatever it is, maybe positive, maybe negative, 3x, like that. Okay. Now, this isn't correct because if I were to put 4 in there, 3 times 4 is not 8. 3 times 4 is 12. Okay, so what we need to do is adjust it so that it becomes 8. What can I do with 12 to make it 8? Well, I can subtract 4. Okay, now this will be correct. To demonstrate why it's correct, I can pick any number. I'm going to choose 5. If I were to put 5 in there, just like the previous problem, it'll come out to be 11. Okay. If I were to put 6 in there, it would be 14 and so forth. Let me show you one more example of that. Of course, you can pause at any time. So in the video, you don't have to worry about me going too fast because you can just pause it if you need to and think about it for a minute. Okay, how about we have something like this? Okay, this time we're going up by 7. In this section, it's always going to be that. You're always going to be going up by the same amount every time. Well, here we're going up by 7. All right, so remember what I told you, do f of x equals 7x. But again, it's not right. Sometimes you might get lucky and it might be right away, but it's not here. So if I put a 2 in there, I get 14. I'm supposed to get 1. So what can I do to 14 to make it turn into 1? Well, you want to either add or subtract. I didn't say that last time. So 14 minus 13 makes 1. Okay, so that would be your answer. And you could test it one more time. If I stick a 4 in there and just pick one, if I stick a 4 in there, 13, f of 4 is 28 minus 13. If I can draw a 3, f of 4 is equal to 15. And that's what it should be, as you can see here. You don't have to do this. This is just a check. Okay? So I'm at 6.